Assalamualaikum and hello and welcome to Baby Step Med, where I try and make difficult medical concepts a bit easier. In this video I will be going through the physiology of inflammation, and as you can see it looks like a lot, but it really isn't. Just like follow through and it will make sense. So these are all the things that are happening in inflammation, and I'm gonna start off. Let me just make this in focus. Okay. So first of all, the main fighters are your neutrophils and macrophages, right? They're in the blood, okay? And macrophages are as monocytes in the blood, okay? So they're here and they're here, and these are spaces in between your capillaries, and the neutrophils and monocytes, they like crawl through, and this is called diapedesis. Through diapedesis, so they crawl through, this means foot, right? And they're in the tissue spaces, right? And they move here by the amoeboid movement, so they move like amoebas, right? And they're attracted by chemotaxis, okay? This is an inflamed tissue, and we call movement by chemicals. And what is this caused by? It's caused by bacterial toxins. We have degenerative products of the inflamed tissues. There are reaction products of the complement complex. There's also products of the plasma clotting, and all of this stuff, right, it just attracts the neutrophils towards the inflamed tissue. And the chemotaxis is like directly proportional to the concentration gradient of the chemotactic agent. So basically, if you have more chemotactic agents, there's going to be more chemotaxis, which means there's going to be more neutrophils here. So it's like a very self-sufficient kind of cycle. And then we have phagocytosis. Okay. So the first step is attachment. So this is it. It's gonna like attach to it, and then it's gonna project out pseudopodia. Okay. And the pseudopodia, they meet and they try to fuse together. So this is them fusing. This is them fusing too. And they invaginate into like a chamber, right? And then this invagination causes the formation what we call a phagosome, right? It breaks away from the outer chamber cell membrane, and then we have it basically gets destroyed by intracellular enzymes and bactericidals. How is that done? So basically this is your phagosome, this is a lysosome, and then we have cytoplasmic granules. And they basically fuse and dump digestive enzymes and bactericidal agents into the phagosome, and then we have a digestive vesicle that's formed, and then the digestion starts. So as you can see, they're like sending stuff out. I don't know if you can see or not. Yeah. Okay. Okay. So what does the lysosome has? It has proteolytic enzymes, all right? It has lipases, which digest the thick lipid membranes of some bacteria like TB, okay? So this is what digestion is. If that fails, then they're killed by the bactericidal agents, which are really powerful oxidizing agents, which are formed by enzymes in the phagosome, okay? Or they're formed from perioxysomes, and they include stuff like superoxide, hydrogen peroxide, and hydroxyl ions, okay? And then they also use the help of chloride ions, which then forms, so hydrogen peroxide plus chloride ions, this forms the really, really lethal compound called hypochlorite. And the lysosomal enzyme amyloperoxidase catalyzes this reaction. So that is what's basically happening, and then we're on to how the actual inflammation takes place. So we basically have 4 lines of defenses. There's the first line, second line, third line, and fourth line. So we're going to start off with, let me just zoom in a little bit. We are going to start off with the first line of defense, which is the skin and mucous membranes, right? They block the pathogens by walling it off, by the walling off effect. And you have tissue macrophages, which start phagocytosis within the first few minutes, okay? And the second line of defense, okay, is now Then, for example, if there's an injury, what's going to happen? Vasodilation, right? So that you can get increased oxygen to the injury site, you can get more nutrients, you can dilute the toxins, and then the neutrophils gather there, so which causes neutrophilia, right? And then we have the second line of defense, okay, in which we have two responses. So there's the vascular response and there's the cellular response. In the vascular response, we have two things happening. We have increased blood flow, which then causes redness and heat, obviously, because when you have more blood is warm and it's going to be like, you know how it goes. And then secondly, we have increased capillary permeability. So once you have more pain, the receptor sensitivity increases, and because fluid from the capillary enters into the interstitial space, so there's swelling, and so that is why we have pain and swelling, because of increased capillary permeability. Then we have the cellular response, in which we have four things happening. We have chemotaxis, cellular adherence, cellular migration, and neutrophilia. Okay, so the chemotactic factors like tumor necrosis factor and interleukin-1, etc., they attract inflammatory mediators, which like neutrophils. Then we have cellular adherence. So adhesion molecules and integrin molecules on neutrophils, they cause marginalization. And then we have cellular migration. There are openings made, and the neutrophils crawl through from the blood into the tissue spaces by this process called diapedesis. Pedesis is like foot, so they're just like crawling in, literally. And then we have neutrophilia. Then we have the third line of defense, okay? Why is this not in focus? Okay. In which the monocytes enter the inflamed tissue to become macrophages, okay? So now the big guns are out. And it's a slower buildup because the monocyte pool is smaller, and this happens through a process of days and weeks, okay? Depending on the infection. Then we're on to the fourth line of defense. We have increased production of mono and granulocytes from the bone marrow. Okay, so we have a constant supply, and the stimulation of mono and granulated progenitor cells. And this maturation takes about like 3-4 days. Now, okay, because we have an increased production of this, we have the formation of pus, right, in which your neutrophils and macrophages, they die, and there's a cavity formed in the inflamed tissue which is filled with the necrotic tissue and dead neutrophils and dead macrophages and tissue fluids. And then we have what we call pus, and this autolyzes and the end products are absorbed in a few days, and that is the whole process of inflammation. Okay, here's an overview. So really simple. First of all, first line of defense, skin and tissue macrophages. Second line of defense, we have the neutrophils. Third line of defense, we have monocytes becoming macrophages. And then we have increased production of all of these things. And then we have pus, which just then autolyzes and the end products are absorbed. Yeah, that's it. I really hope that this helps. Please like and subscribe, and bye.